All right, problem one, we're trying to figure out which of these answers could represent this function here. So this function we have h of t is equal to negative 35t plus $2,500, or plus 2,500, assuming we're going to be dealing with money in every equation. We want to basically look at this in terms of like what this negative 35t means. This negative 35 means we're decreasing by 35 every time t goes up by 1. And this 2,500, that, on a graph is the y-intercept, but think of this as the starting value. In context of a problem, it's usually going to be the starting value of, whatever you're talking about. So since we're talking about money here, this is basically saying that like he started with $2,500 and then he lost $35 every time t went up by 1. Maybe t is like days, maybe it's months, maybe it's years, but let's see which of these makes sense. So the first one says he has $2,500 in the bank account and he plans to deposit $35 each month. So since it says deposit, that means we're increasing. So it's not going to be A. B, Anthony has $2,500 in his bank account. He plans to deposit $1 every 35 days. Again, we're saying deposit, so we're saying it's going to have an increase. So it's not going to be B. C, Anthony has negative $35 in his bank account, and he just won $2,500. This is all wrong. So let's not even worry about that. And D, Anthony has $2,500 in his bank account, and he plans to withdraw $35 each month. So that withdraw means it's gonna lose money every month. So the T we can say is basically the number of months. And then this is gonna be a good example of answer D. Problem 2, which function can represent the data in the table below? So one way to basically just check is to just test these values into your equations. Remember, this is the input. The x values are the inputs, and the y values are the outputs. So if you put -5 into the equation, you should get out -11. You put 0 in, you should get out -1. If you put 2 in, you should get out 3. If you put in 5, you should get out 9. So usually we'll use y as the output as our variable, but f of x, y, they mean the same thing. Okay, so let's look at which one would make sense. Okay, so problem A says, or answer A says, f of x equals -2. This is not going to be the answer because it's saying that the output is always -2. It's not always -2 because you can see it's different. So it's not going to be A. B, we have f of x equals x plus 3. So let's test this one. So for example, if we plug in -5, f of -5, that'll be -5 plus 3, which should be -2, which means -2 is our output. As an ordered pair, this is -5 and -2. So when you plug in -5, you should get out -2. But when we plug in -5, we're supposed to get -11. So it's not going to be B. Problem C, we plug in -5, f of -5. We'll get -5 minus 3. We'll get -8. So we have a -5 for x, -8 for y, and that's still not our answer because we're supposed to get -11, so it's not going to be C. Problem D, let's see, f of -5. We plug in -5, we get 2 times -5 plus 1, or -10 plus 1, which is -9. So it still ain't right because we're supposed to get -11. So it's not going to be D. I mean, we know it's going to be E then, but let's just go through it to be sure. So f of -5, 2 times -5 minus 1, -10 minus 1, and we get -11. And so that works out because we're going to have -5 with an output of -11. So the answer is E. All right, problem 3. We're going to evaluate g of 8 when g of x is this piecewise function. So the key in piecewise functions is essentially to pay attention to the intervals here. These intervals basically tell you which expression to plug the x value in when it lies in these intervals. So like when x is less than or equal to 5, you're going to plug x in here. If it's between 5 and 8, you're going to plug it into here. And if it's greater than or equal to 8, you're going to plug it in here. So this says evaluate g of 8. So we're evaluating when x equals 8. So g of 8 is going to be plugged into here because x is greater than or equal to 8. So then g of 8 will be equal to 8 minus 8. And g of 8 will then just be equal to 0. Now in part B, we're asked to find g of 5. So we're then just asked to figure out what to plug it into when x is 5, because we're basically taking the input of 5. So 5 is going to be into this one because this is saying if x is less than or equal to 5. So we're going to plug 5 into this expression. So g of 5 is going to be 5 minus 2 times 5, which is just 5 minus 10, which is going to give us -5. All right, next we got, given that f of x is x squared minus 3 and g of x is 2x minus 1, find gf of x. So this is essentially the notation we use when we multiply g of x by f of x. So we're going to multiply g of x by f of x. So this is going to look like this. This is going to be equal to 2x minus 1 times x squared minus 3. And for this, we just have to make sure we distribute. So 2x times x squared will give us 2x cubed. 2x times a minus 3 minus 6x. -1 times an x squared minus 1x squared, or just minus x squared. -1 times a -3 is plus 3. And just to put it in standard form, we're going to write 2x cubed minus x squared minus 6x plus 3. There are no like terms, so we can't combine anything, and this is just going to be our answer. Okay, part B is then asking find g minus f of x, which is essentially g of x minus f of x. So then we just simply have 2x minus 1 minus x squared minus 3. And then we just have to make sure we distribute this negative symbol correctly. So then taking away the parentheses, we're going to get 2x minus 1 minus x squared minus a minus 3, or plus 3. This is not multiplying. Don't make the mistake of multiplying. So then again, putting it in standard form, we're going to write negative x squared first, then plus 2x, and then minus 1 plus 3 make a plus 2. All right, and then we have, given that f of x is negative 2x plus 7, and g of x is 2x squared, find g of f of 2. So the idea here is to find first f of 2, find the inside. And this is just plugging 2 into this equation, which will give us negative 2 times 2 plus 7, which is going to be negative 4 plus 7, which will be 3. Then we take this 3 and then plug it into the g function. So we want to calculate g of 3. So g of 3 then is 2 times 3 squared. Or just 2 times 9, which will give us 18. And that's our final answer. All right, next page we got. And now we're graphing some piecewise functions. Okay, so when you're graphing piecewise functions, again, I would recommend pay attention to the intervals. So we have the intervals broken up at negative 2. So I like to draw a vertical line through x is negative 2. Just to make it stand out. So this is x is negative 2. And what you're going to do is you're going to graph this expression to the left of negative 2. And then you're going to graph this expression to the right of negative 2. Now, you can always use your understanding of slope-intercept form and all that, but in case you're paranoid about making a mistake, just plug in a number and then calculate. So plug in something like any of these numbers to the left here. So I mean, you could plug in, let's plug in negative 5, for example. So f of negative 5, we're going to get negative 3 times negative 5 minus 4, 15 minus 4. And we're going to get 11. So that means we're going to have 1 point at negative 5 comma 11. Whoa. What's going on here? So negative 5 comma 11. 1, 2, 3, 4, 5, negative 5 comma 11. Something like over there. And then maybe plug in one more at let's plug in negative 2 actually. So I can explain this. We're going to plug negative 2 into here. And you would get 6 minus 4, giving us 2. And you would have a point at negative 2 comma 2. But technically, we're not supposed to include negative 2 for this expression, because see, it says less than. It doesn't say less than or equal to. So then at negative 2, 2, you would have an open circle. And since this is a linear equation, since it's a slope of negative 3, we can go up 3 from here. 1, 2, 3, and to the left 1. Up 3 to the left 1. And see, it's going to connect in a straight line. And it doesn't stop there. It would go infinitely to the left. Now the next one, 3x, we can plug in, again, -2. And when we plug in -2, we're going to have a solid circle here. So this one's going to be pretty simple. F of -2 would be just 3 times -2, or -6. So we're going to have a closed circle at -2, -6. It's like right there. And let's just plug in one more. Let's plug in -1 just to be sure. So F of -1, we can, do it pretty easily. It'll just be -3. So we're going to have another point at -1 and -3. And that makes sense because, let me write it out, -1, -3. Because we're going to have a slope of 3, because this is 3x. So we're going to be going up 3 to the right 1, up 3 to the right 1, and just all the way until we get off this graph. And there we go. All right, next one, we have this piecewise function, f of x is x squared plus 2 squared if x is less than or equal to 1, and it's equal to 8 if x is more than 1. So again, we're going to draw a vertical line at our boundary, x is 1. Let's first do this one. This one's pretty simple because this is just saying that f of x equals 8 when x is greater than 1. So we're not going to include 1, 8. So we just draw an open circle there. So at 1, 8. 1, 2, 3, 4, 5, 6, 7, 8. We put an open circle. And then we just keep on drawing points going to the right, because this is our line y equals 8. Now this is going to be a parabola. So make sure that you don't draw like a straight line, because you can see the power here. But the way you could always do this is plugging in 1, plugging in 0, -1, -2, -3, -4, -5, and so forth. So let's just make a table down here. Maybe zoom out a little bit. So I'm just going to write the points quickly, just so I don't spend time calculating it, but just, obviously try to make sure that you know how to calculate these properly. But plug in a -5, -5 plus 2, -3, -3 squared will be 9. Plug in a -4. We're going to get then 4, because we're going to have -4 plus 2, 2 squared, 4. -3 will give us 1. -2 will give us 0. -1 will give us 1 again. 0 will give us 4, and 1 will give us 9. So we're going to have a point at -5, 9. 1, 2, 3, 4, 5, 5, 9. -4, 4. So 1, 2, 3, 4. -3, 1. -2, 0. -1, 1. 0, 4. and then 1, 9. And then, so this is what your parabola is going to look like on this part of the graph. Let's make sure we stop it there. That point is going to be 1, 9. All right, the next one, we're going to go backwards and we're going to then make a piecewise function. So we're just going to write the equation essentially. So this one shouldn't be too bad because we have straight lines. So we're going to have linear equations. So we remember slope-intercept form, y equals mx plus b. So for this one, we're going, looks like our slope down 2 to the right 3. So our slope here for this first one would be negative 2/3. Down 2 to the right 3, down 2 to the right 3. So then we know negative 2/3 x, but then we have to solve for the b part. And if you're like kind of just worried about like making a mistake with looking at the graph, then just calculate it. So then see, we know it goes through 1, 3. So then let's just solve this equation for 1, 3. So we can plug 1, 3 into here. So we're going to get 3 equals negative 2/3 times 1 plus b. So we have 3 is negative 2/3 plus b. Add 2/3 to both sides. So then we get 3 plus 2/3, or we get 11/3 equals b. Then our equation is going to be y is negative 2/3 x plus 11/3. So then we're going to put plus 11/3. But again, we have to make sure we pay attention to the interval. So we're going to say if, remember, it only happens, it goes up to this line here. And this line is x equals 1. So it goes up to x equals 1. And since we have a solid dot there, we can say if x is less than or equal to 1. Now the next graph here, where the slope here is going to be 1. This is pretty simple. Slope for that graph will be, let's write it down here. Slope is 1/1 or just 1. And don't put the y-intercept as negative 2. Like the y-intercept would be what would happen if you kept on going. So the y-intercept here would be negative 3. So then the y-intercept, or b in this case, would be negative 3. And so our equation for this one would be 1x minus 3. So then we can put 1x minus 3. But again, consider the interval. So that's if x is going to be greater than 1. We don't include 1 because, see, there's an open circle there. Let me erase this part because I don't want it to confuse you. So we're going to have just if x is greater than 1 for that one. All right, moving on. Page 3. All right, here, this is really just knowing notation. It's actually pretty simple. So we're given that f of x is this equation and that g of x is this equation. And for part A, we want to find f plus g of 2. All this means is to find f of 2 and then add it to g of 2. So we just plug 2 into this. So f of 2 would be 2 squared minus 5 times 2 minus 14 plus, let me put this in red actually, plus g of 2. So plugging 2 into there. And then evaluating this, 4 minus 10, negative 6, minus 14, negative 20, plus negative 5. And so our answer is negative 25. For problem B, this is saying f minus g of 5, which is just f of 5 minus g of 5. So pretty much the same idea, except we're just going to subtract after we plug in 5 into f and g. So let's find f of 5. That would be 5 squared minus 5 times 5 minus 14 minus, plugging 5 into there, 5 minus 7. So we get 25 minus 25, 0, negative 14, minus 5 minus 7 minus negative 2. And this becomes negative 14 plus 2, which is just going to give us negative 12. All right, for C, now it's just the other way around. We're just doing g minus f of negative 1. So we're going to take g of negative 1, and then we're going to subtract f of negative 1. So plug in negative 1 into there. We're going to have negative 1 minus 7 minus, plug in negative 1 into here. Negative 1 squared minus 5 times negative 1 minus 14. So negative 1 minus 7, negative 8, minus 1 plus 5, 6, 6 minus 14, negative 8. And we end up with just negative 8 plus 8, which is just going to give us 0. Right, problem D, we have fg of negative 5. This is just multiplying f of negative 5 by g of negative 5. So let's find what f of negative 5 is. So plug in negative 5 into there. We get negative 5 squared minus 5 times negative 5 minus 14. This is going to be multiplied by plugging negative 5 into here. Negative 5 minus 7. So 25 plus 25, 50. So we get 36 times negative 12. And we get negative 432. All right, next we have f over g of 2. So you probably get the idea now. We're going to have f of 2 divided by g of 2. So f of 2, plug in 2 into f of x. So we'll get 2 squared minus 5 times 2 minus 14. Then plug in 2 into g of x. So we get 2 minus 7. And we already calculated actually f of 2. Look, we already calculated f of 2 to find, we found negative 20 and g of 2. So we could just use that. So we get negative 20 over negative 5, which gives us our answer of 4. F, now we got g of 10 over f of 10. So evaluating g of 10, we're going to have 10 minus 7 on top. F of 10, plugging 10 into there, we'll get 10 squared minus 5 times 10 minus 14. Ten minus 7, we're going to get 3 on top. 100 minus 50, so 50 minus 14, so 36. And then we end up with 1/12. All right, and these last two, we have composite functions. So we want to find the inside first. So let's find g of 2. And then whatever we get for that, we're going to plug into f. The g of 2, we're just going to get 2 minus 7, which is just negative 5 again. Then we plug this negative 5 into f. So we're going to then, going back around, f of negative 5. We actually already found f of negative 5 here because we calculate. So it's just 36. So we can save some work there. So our final answer is this, 36. All right, inside again. So our inside is f of 5. So we have g of f of 5. Let's first find f of 5. Which we actually already found here too. So f of 5 is negative 14. This negative 14, then we plug it into g. So we're going to take g of negative 14. So plugging negative 14 into g of x, we're going to get negative 14 minus 7. And our final answer will be negative 21. All right, last part. Some more piecewise graphing. So here we have a piecewise graph broken up into 4 intervals. See, we have x is less than or equal to negative 2, x is between negative 2 and 2, and x is greater than or equal to 2 and less than or equal to 4, and then x is greater than 4. So I recommend first drawing like vertical lines dividing the graph at these points. So at negative 2, and then at 2, and then at 4, and then now you know like to plug this first graph over here. The second one is going to be in this region. The third one will be in here, and the fourth one will be to the right of 4. So our first equation is just basically think of it as y equals -4. Y equals -4 goes in here. This is going to be just a horizontal line from -4 beyond. So we're just plotting dots at -4. And we're saying less than or equal to -2. So we're going to have a closed circle at -4. Or a closed circle at -2, -4. And this graph will just be like that. Now in this region, we're going to plot the line y equals 1/2 x minus 1. This is pretty going to be pretty easy because we're just going to use slope-intercept form. And since we have the y-axis in here, we can start off at -1. That's going to be our y-intercept. And our slope is 1/2. We're going to go up 1 to the right 2. And down 1 to the left 2. Make sure you put open circles at those endpoints because, see, you're not including -2 and 2. So then your graph is going to be like this. And here is going to be the quadratic. There you're going to have y equals x minus 3 squared. And you're going to include the endpoints 2 and 4. So what I would recommend is to just basically just plug in 2, 3, and 4 into this equation, and then calculate whatever you get. So then let's just do that. Plug in 2, 3, 4. You plug in 2 into here, you're going to get 2 minus 3, -1, -1 squared will be 1. Plug in 3, 3 minus 3 is 0, 0 squared is 0. Plug in 4, you're going to get 4 minus 3, 1, 1 squared is 1. And so you're going to have 1 point at 2, 1, right here. Another point at 3, 0, over there. And then your other point at 4, 1. Oh, here's your parabola. And again, we have closed circles at the end because we're saying that we're going to include -2 and we're going to include +2 and +4. Now the last one is just going to be y equals 3. So it's just going to be a horizontal line at 3, but open circle here because we're not including 4. So an open circle here to the right, and that'll be that. All right, this other piecewise graph. Again, start off with the intervals. Let's make vertical lines at -1, 1, and at 3. Now the first graph we have y is -x minus 2, which is going to be in here. This next graph in here will be y equals -4. Next one is y equals x squared. And the last one is y equals 2x minus 2. Now this is a linear equation. So then you know it's going to be a straight line. So then just plug in 2 points. I would just plug in -1 and like -2. So then let's go ahead, let's do that. X is -1, and if X is -2, plug in -1 into here will be -1 times -1. So it'll be 1, 1 minus 2. This will give us -1. So then we're going to have a point at -1, -1. Plug in -2 into there. It will be negative times -2. So +2. +2 minus 2 is just going to be 0. So then we're going to have another point at -2, 0. So -2, 0, -1, -1. Closed circle because we're including -1. And this makes sense because see the slope is -1 because it's negative x, or just think of this as -1 times x, same thing. So your graph is going to look like this. Now the next piecewise is going to be y equals -4 from here to here. We're not going to include -1 and 1, so we're going to have open circles there. So then it's just going to be a horizontal line like this. The next portion is going to be y equals x squared. So we're going to have a parabola. So I would advise plugging in 1, 2, and 3. And we're going to include 1 and 3. So we're going to have closed circles at the endpoints. So let's make another xy. 1, 2, 3. I guess I didn't really have to make another xy label. But anyways, so plugging in these into here. So this is pretty simple because it's just 1 squared, so 1. So we'll get a point at 1, 1. Plugging in 2, 2 squared is 4. So we have another point at 2, 4. Plugging in 3, 3 squared is 9. So we have another point at 3, 9. And so then we just graph those. So at 1, 1, 2, 4. And 3, 9 is going to be way up here. So maybe something like this. And we're going to have a parabola. All right, and the last one, we have y is 2x minus 2. So then we can plug in 3 and 4 and just you can go from there. But we're going to have an open circle at 3. So another xy. Let's just plug in 3 and 4. Plugging it into this. So 3 into x, so 2 times 3, 6 minus 2 gives 4. So we have a point at 3, 4. Plug in 4 into here. 2 times 4, 8. 8 minus 2, 6. So we have another point at 4, 6. So open circle at 3, 4. Closed circle at 4, 6. And it's going to veer off to the right like that. All right, so there we go. I hope that helps. Let me know if you have any questions, and I'll try to clear it up. And good luck with this. I'll see you guys in the next video.